Sir Isaac Newton, who lived in 1643 to 1927, discovered a lot of theory, and part of the theory is the numerical solutions. And in numerical solutions, we have the Newton-Raphsons iteration methodology, which is given as xn plus 1 is equal to xn minus f of xn divided by f prime of xn. This is referred to as Newton-Raphsons iteration formula. So that if you are given a question such as f of x is equal to s cubed plus 3x squared plus 1 at x not equal to 3, for example. Of course, okay, if we reduce it, we can even remove this 2 and say s cubed plus 3x plus 1 f of x, and the initial value is 3. If initial value is 3, it means that when n is equal to 0, when we say n is equal to 0, that is to say that if n is equal to 0, we substitute it back into the Newton's formula, which is x0 plus 1 equal to x0 minus f of x0 divided by f prime of x0. Alright, now this gives us first iteration of the Newton-Raphsons model will give you x1 is equal to x0 minus f of x0 divided by f prime of x0. So that by virtue of substitution, x0 has been given as 3. Yeah, that's the initial value. They will give you the initial value. If this initial value is given, we substitute x0, which is 3, minus f of 3 divided by f prime of 3. Whereby, note too that f of x ab initio is equal to s cubed plus 3x plus 1. So f of 3 therefore is equal to 3 cubed plus 3 times 3 plus 1, and that is equal to 27 plus 10, that is 9 plus 1. So this gives us exactly 37 as the numerical value for f of 3. Furthermore, the derivative of f prime of x is equal to 3x squared plus 3. When we differentiate this, 3 comes down, we subtract 1 from it, we get this. Differentiate 3x, we have 3. Differentiate 1, it comes to 0. So therefore, f prime of x0 is equal to 3x0 squared plus 3. Now, what we do is to substitute the value of x0, which is going to be 3 multiplied by 3 squared. 3 multiplied by 3 squared plus 3. And this gives us 27 plus 3, which is 30. Therefore, what we also do is to come to the Newton-Raphsons formula, which is this to give us, therefore, x1 is equal to x0 minus f of x0 divided by f prime of x0. So that our value finally for x1 is equal to x0, which is 3, minus f of 3. F of 3 is 37 divided by the value of f prime of x0, which is the derivative function at the denominator, and that gives us exactly 30. So when this is result, we'll be having x1 is equal to 3 minus, when we divide 30 into 37 is 1. 30 into 70, we are now going to get 3. Now remember, no, of course, 30 into 70, we are having 2. Then the last value will be 3 into 100 is 3 approximately. So if we subtract this value, because 37 divided by 30 is 1.27. 30 into 37 will give us 1. It cannot go into 7, add 0, put decimal point. 30 into 70 will give us 2. Remainder 10. Add 0 to 10, Now that gives you 100. So when it goes into 100, it gives you 3. That is 90. So we can summarize. You can summarize it as 1.23. Subtract 1.23 from 3. You have x1. Therefore, you now have it that x1 is equal to 1.77 approximately. 1.77 approximately, and that is the answer. Take note that Raphsons iteration belongs to the root method of numerical analysis. The root method of numerical methods. Now, it is key and pertinent to know that it is higher than the secant and tangent methodology and the bisection methodology. So, Sir Newton's application of Raphsons iteration is key and fundamental in numerical analysis.